All right, today we're diving into a really fascinating new formal framework for the semantics of Tokyo Japanese, laid out in a manuscript by Junichi Aida. What's so exciting about this is that it proposes a single, unified semantic engine that derives meaning by pulling together particles, prosody, and syntax all in one compositional process. So let's kick things off with a classic puzzle from Japanese linguistics, the shika-nai construction. You have a sentence like mugi shika kawaiku nai, which means only mugi is cute. But here's the problem. The predicate, kawaiku nai, literally means is not cute. So how on earth do you get from is not cute to a sentence that means only mugi is cute? This is the puzzle at the very heart of Ida's framework. To crack this puzzle, the manuscript lays out a whole new framework, and it starts with a pretty elegant idea borrowed from mathematics, function application. Okay, so the first big move here is to stop thinking about constructions like mugi shika as simple static phrases. Instead, the framework treats them as functions. In this view, mugi shika isn't just a noun and a particle. It's a higher-order function that's waiting for an argument. It takes the negative part, nai, and in return, it gives you the meaning only mugi. It's a fundamental shift in type, and it's absolutely key to the whole derivation. Now, here's where things get really innovative. The framework introduces this idea of a context. It says that anytime you mention a topic, let's call it X, you automatically bring two other things into the conversation, X prime and X double prime. These are basically the contextually relevant alternatives to X. This is the mechanism that's going to let us calculate all those tricky, exhaustive, and contrastive meanings. So let's bring it back to our sentence. With this machinery of prime topics, the meaning just falls into place. The sentence, mugi shika kawaku nai, is compositionally built to mean a set of three things. 1, mugi is cute. 2, mugi prime is not cute. And 3, mugi double prime is not cute. And there you have it. That's how we formally get the only meaning. Okay, but wait, how does the grammar know to match mugi with is cute and the alternatives with is not cute? For that, Ida introduces a really slick formal tool called the vinculum. It's just that horizontal line you see there. Its whole job is to act as a separator, neatly dividing the semantic bits and pieces of both the topic and the predicate into their positive and negative parts. And this diagram shows you exactly how it works. It's beautiful. Step 1, the topic, mugi shika, gets represented with mugi below the line, and the alternatives, mugi prime and double prime, go above it. Step 2, the predicate does the same thing. The positive part, is cute, goes below the line, and the negative part, is not cute, goes above. And then step 3, the nodes merge. The grammar just matches the stuff above the line and the stuff below the line. And just like that, you've derived the correct meaning. Puzzle solved. So the framework handles our shika-nai problem. But the real test of a theory, right, is how it scales. And its power really shines when we apply it to those notoriously difficult Japanese particles, ga, wa, and mo. Let's start with the particle ga. The linguist Susumu Kuno famously laid this out back in '73. Ga can have two totally different readings. It can give you a simple, neutral description like, it is raining, no big deal. Or it can give you an exhaustive listing reading where John ga gakusei desu means John and only John is a student. For a long time, these were basically treated as two different gas. And here's a really cool piece of linguistic history that Ida uncovers in the manuscript. You know, Kuno gave credit to Shigeyuki Kuroda in 1965 for being the first to spot this distinction. But Ida points out that way back in 1914, a guy named William Imbrie was already describing the very same exhaustive versus neutral distinction, half a century earlier. But here's the real payoff. The beauty of Ida's framework is that it models all these different particles using the exact same system. As you can see in the table, the exhaustive reading of ga has the exact same semantic representation as shika-nai. Contrast of wa, that's just what you get when you only use one alternative topic, x prime. And the additive particle mo, that's what you get when you assert the predicate for both the topic and its alternative. It's an incredible display of formal economy. Okay, so the system handles particles, but its reach goes even further into one of the most subtle areas of language, the sound of meaning. We're talking about prosody, specifically phonological stress. So check this out.
on the screen are two sentences. They have the exact same words, yoshimi wa isogashi. The only difference, marked by that $sign, is where the stress falls. If you stress yoshimi, you get a contrastive meaning. Yoshimi is busy, implying someone else isn't. But if you stress isogashi, you're just focusing on the state of being busy. How can a formal system possibly account for that?
Well, the framework models this by analyzing what it calls the sentence's commentary, basically the set of propositions that make up its meaning. When the stress is on the predicate, isogashi, the system's focus operator highlights the positive parts of that commentary. The result is a simple, predicational focus on being busy. But watch what happens when we shift the stress. When the stress is on the topic, yoshimi, the focus operator instead highlights the negative proposition in the commentary, the one about the alternative, yoshimi prime. By making the statement yoshimi prime is not busy, the most salient part of the meaning, the formalism directly derives that contrastive reading. It's really elegant. Now, this framework isn't just for simple sentences. It's designed as a complete semantic engine that can handle much more complex structures, like sentences that have relative clauses embedded in them.
Let's walk through how the engine builds a sentence like, drank only milk that is tasty. First, the system derives the relative clause, is tasty, and it gets finalized with a special indexed mood marker. Think of that index as a key. That clause can then only merge with a noun that has the same index, the matching lock, in this case, mirepu, or milk. Once they combine, you get the complex noun, milk that is tasty, and that whole chunk then slots right into the main sentence derivation. It shows how recursive and powerful the system is.
So when you take a step back, what Ida's framework offers is a deeply unified semantic engine. It derives the meaning of particles, prosody, and complex syntax using the same fundamental tools, primed topics, and the vinculum. And that leaves us with a pretty provocative question for the field. If you can really unify phenomena that we normally handle in separate modules, what does that imply for our models of the interface between phonology, syntax, and semantics?